At this point, we now have the prototype software is still running on Mars in the orbiters and on the landed rovers. And as you know, we've now sent several spacecraft to Mars onto the surface. There's Spirit and Opportunity have basically stopped working, but the Mars Science Laboratory and Curiosity are there, and we have more things planned in the 2020s. The second thing is that we have the most recent standardized versions of the protocols are running on the International Space Station now. They're being used by the astronauts. A couple of years ago, we tested those protocols in real time, driving a small rover here in Heidelberg around under the control of an astronaut. The only reason we could do that is that the distance between the International Space Station and Heidelberg is fairly short, and so there's low latency. So if you turn the steering wheel on the International Space Station, the wheels turn very quickly on the little rover. That doesn't work from here to Mars because the round trip time delays could be up to 40 minutes. And you can't imagine driving a car where you turn the steering wheel and 40 minutes later the wheels turn. So we needed to know that the protocols would work in both low latency in real time and also handle the high latency. The other thing that we recently did was a test using an optical transmission bouncing off of the moon. So it was at 600 megabits a second. Now the moon distance is still fairly close. It's about 2.5 seconds round trip time. But the fact that we could run the protocol at 600 megabits a second using an optical laser was very satisfying, because it suggests that when we start using lasers instead of radios to communicate information back and forth from the spacecraft that are in the rest of the solar system, that we'll be able to get more data back. So at this point, it's my understanding that the European Space Agency, the Japanese Space Agency, the Korean Space Agency, and NASA have all agreed to make use of the interplanetary protocols that have now been standardized in spacecraft that are being built after 2020. And so in the American program, one of the more exciting new developments is called Gateway. And if you follow that one, it's a spacecraft, and possibly an aggregated one, just like the International Space Station is an aggregate of components. Gateway will be an aggregate of components in a very eccentric orbit around the moon. And so, roughly speaking, you leave Earth and then rendezvous with the Gateway spacecraft, and then ride the Gateway spacecraft to the moon, and then take a shuttle down to the moon. And then you do whatever you have to do, and when the spacecraft comes back, you take the shuttle back up, and then you ride the Gateway spacecraft and pick up another spacecraft to get back to Earth. So it's like having escalators in the sky. Those systems, we hope, are also going to make use of the interplanetary protocols. So at this point, the idea is alive and well, and it's beginning to propagate.